Hello Year 12 and welcome to this short video on measuring angles, and in particular in this video I'd like to introduce the idea of radians. And I'd like to start by asking this simple question here of finding the value of x here. So just pause your video and give yourself 30 seconds to solve that. So what do we know? Well, we already know that the angles on a straight line sum to 180 degrees, so we know that x must be equal to 180 subtract 70 subtract 50, which is 60 degrees, and that's nice and easy. But why was it that we know that the angles on a straight line sum to 180 degrees? Well, that's essentially just an arbitrary choice that we made. One of the reasons might be that 180 degrees is really easy to divide. It divides by 2, it divides by 3, it divides by 4, it divides by 5, it divides by 6, etc. So it's a nice number for doing division. But we could have made other choices. We could have said that the angles on a straight line sum to pi, and that's exactly what we're doing with radians. So radians is an idea if we measure the angle by saying that the angles on a straight line sum to pi radians. So again, I want you to pause your video and now, using the fact that the angles on a straight line sum to pi radians, find the value of x here. Well, what do we know? We now know the angles on a straight line sum to pi radians. So we know that x is equal to pi subtract pi over 6 subtract pi over 3, which is, writing a common denominator of 6 pi over 6 minus pi over 6 minus 2 pi over 6. So what is that? That is going to be 3 pi over 6, and simplifying that, that is pi over 2. And notice that this is half of a straight line, because if pi radians is a straight line, pi over 2 radians is half of a straight line, also known as a right angle. Okay, so if we know that a straight line the angles on a straight line sum to pi radians, then the angles around a point must sum to 2 pi radians. So again, pause your video and try and find the value of x here. So we know that x is equal to 2 pi subtract pi over 2 subtract 3 pi over 4 subtract pi over 4, which is, writing a common denominator of 4, 8 pi over 4 subtract 2 pi over 4 subtract 3 pi over 4 subtract pi over 4, which is 2 pi over 4, which simplifies to pi over 2. So notice again, this is half of a straight line, or half of a half turn. This again is a right angle. Right, and one more similar example here. If the angles on a straight line sum to pi radians, then also the angles in a triangle sum to pi radians. So pause your video and again, please just spend 30 seconds, find the value of x and y in radians. Okay, so this is an isosceles triangle, so we know that x is equal to y, and we also know that x plus y is equal to pi, the sum of the angles in a triangle, subtract 2 pi over 3, which is 3 pi over 3 subtract 2 pi over 3, so that is pi over 3. But then we know that x equals y plus x, so x plus y is 2x, so 2x is equal to pi over 3, which means that x is equal to pi over 6, which is also equal to y. And notice that this here is 1/6 of a half turn, so 1/6 of a straight line, which is the same thing as saying 1/12 of a turn. And this idea is going to help us do what we want to do next, which is converting degrees to radians. And I've used this little symbol C here, and this just means radians, and actually we start to drop this. But for now, let's make it really, really clear. Okay, so pi radians, we know this one already. We know that pi radians is 180 degrees. Well, what about pi over 2? Well, that's one we've met already as well. Pi over 2 is just half of a straight line. Half of a straight line is 90 degrees, which is a right angle. Okay, well, what about pi over 3? Well, there's a third of a straight line. So what can we do there? We can divide our straight line of 180 by 3. So that is 60 degrees. And what about 3 pi over 2? Well, 3 pi over 2, that's 3 lots of pi over 2, or that is 3 quarters of a turn. So that is 3 lots of pi over 2, which is 3 lots of 90 degrees. So that's 270 degrees. But what are we doing here? Well, let's think about what we did here. What we did here is, firstly, we essentially divided it by pi and multiplied by 180. So we divided by pi and times by 180. And we can see that the same thing works here, because if we do pi over 2 times 180 over pi, the pi's cancel and we get 180 over 2, which is 90 degrees. So when we're converting from radians to degrees, we multiply by 180 over pi. Okay, what about degrees to radians? Well, it might not surprise you what the result is here, but let's have a think about it. If we're converting degrees to radians, 45 degrees, if we think about a straight line, 45 degrees is a quarter of a straight line. We can get 4 lots of 45 degrees into a straight line. So that must mean that 45 degrees is pi radians over 4. Well, what about 30 degrees? Well, 30 degrees is a sixth of a straight line. We can get 6 lots of 30 degrees into a straight line. So that must be pi radians over 6. And what about 150 degrees? Well, that is almost a straight line. If we go back to our diagram here, we can actually see that 150 degrees is 5 lots of 130 degrees. 5 lots of 30 degrees. So what must this be? Well, this must just be 5 lots of pi over 6 radians. Well, what have we done here? And this shouldn't be a surprise, because we know that we are just doing the opposite of what we did before. Well, we are multiplying by the reciprocal of 180 over pi. So we are either dividing by 180 over pi, or we are multiplying by pi over 180. And we can see that this is exactly what we're doing, because if we do 45 times pi over 180, we get 45 over 180. Well, we know that that is an eighth. We know that that is a quarter. So this is going to be pi over 4 radians. Finally, I just wanted to mention gradients. Gradients are another way we might go about measuring angles. And actually, you've seen gradients before. If you've ever seen this road symbol, and what this is saying here, a 100% incline is a right angle. So if 100% incline is a right angle, what is a 10% incline? Well, it's going to be a tenth of a right angle. So if this is 100% and this is 10%, well, what is that in degrees? Well, if we're doing this in degrees, a tenth of a right angle is 9 degrees. And if we're doing it in radians, well, we know a right angle is pi over 2. We know a right angle is pi over 2. And if we take a tenth of this, this is going to be a tenth times pi over 2, which is pi over 20. So how we choose to measure angles is up to us. We could use degrees, we could use radians. If we want to, and they chose to on the road signs, they could use gradients. But in some subsequent lessons, we're going to see why radians are a smart choice.